My goodness. So today we are going to start with pressure. Pressure is basically known as, like defined as, great, let me close this file. I'm sorry. No, okay. Pressure is known as force per unit area. Okay. Even if you write force over area directly, you will get the right answer. The SI units of pressure are Newton per meter squared or pascals, written as PA, like that. Then let me know where you get stuck, okay? Pressure, you guys need to remember, is a scalar quantity. And just to tell you this important note here, which you guys should write, and that is that pressure itself, this pressure, force always act perpendicular to the area, like that. Should remember that. Speaking of this, then, you should remember that pressure itself is force over area. And then if you look at these two quantities, you may realize that the greater the pressure is, area, it would be like area would be smaller. Okay. Now, speaking of this, we can look at this example where a person who has this weight is basically standing on a beach with flats and heels, right? So if I want to find the pressure, it would be force over this area. And if you calculate this, then it's going to be 40,000 pascals. The same person, if she was wearing heels, it would be 800 divided by 0.005. So then it would be 160,000 pascals. So you can clearly see that smaller the area, larger the pressure would be. Now, similarly, okay, I wanted to write thumb pin, thumb. Sorry, you can edit this, please. Now, you would always put force on this side and not this side to put the thumb pin in the soft board. That is why, because in this region, you will have greater pressure because pin head area is smaller. Do you guys understand this? Zainab, Yusra, Saleh?
Yes, sir.
All right. So this is the reason why when I was very young, very young like you, I used to get very scared about from the syringes because syringes needles were thicker back then. These days syringes are like much thinner. They're called butterfly syringes. They don't, you feel just a pinch, not a lot of pain. So the reason why you want to keep the needle as thin as possible to make sure there is larger pressure so that you do not need to apply greater force to put it in. And if you do not apply greater force, then the patients the patients do not feel a lot of pain. Do you get my point? Right. So going back just a bit, you guys can copy this and then I go back. Okay. All right. Imal, Caroline, Hussein, Ismail. Do you guys understand this?
Yes, sir.
Yes.
And Kazim. Oh, Maham. Who are you, Maham? Today's spy.
Assalamu alaikum, sir.
Walaikum salam, Maham. Maham, are you new today?
No, sort of, yeah.
Okay, sort of. All right. All right, Maham. Let's follow along then. So the pressure has to be like force per unit area. The basic principle behind this is that you should always remember that force and the pressure and area are inversely proportional. So
All right.
when you have greater area, you get less pressure and vice versa. That is why you would not want to wear heels on the beach because they will sink in.
Okay.
The basic meaning. Hmm.
Sir, could you please move down?
Yes, yes. Wait a second, please. There is some annoying person. Okay. So now, should I go forward now? Everybody has written this?
Yes, sir.
All right. So let's try and do this question. So in this example, they say, which diagram shows an athlete exerting least pressure on the ground? What do you guys say?
B.
B,
B.
sir.
B. Why? So it is basically the
Because
greatest
there's the
area.
greatest area.
Yes, because of greatest area. Very good. You guys are smart. And then in the next question, it says a rectangular container has a base dimensions of this and this. The container is filled with liquid. The mass of the liquid in the container is 4.8. It says calculate the weight of the container. Do you know the formula for weight?
M times G.
M times D. Then next time I do not have to have Like I don't have to message you. All right. You have to come yourself. Is that clear, Zan?
Yeah.
Yes, this is not good. Then mg. So mass is like 4.8 and g now we have to take 9.8. Can you guys help me calculate this, please?
47.0.
47.1.
47.1. So it's going to be
Sir,
47. Yes.
why can we not take the gravity as 10?
In the new syllabus, Maham, it is changed. Now we have to stick to 9.8. All right. 10 is
All
obsolete.
right.
Yeah.
Okay.
Now, so then the pressure due to liquid on the base of the container. Now, pressure is force over area. The issue is we do not have the area, but we have the dimension of the base, right? And because it is a rectangular container, so area would be length into width or breadth. Okay, so it's going to be 0.12. Are you sure about that? 0.0192? 0.0192 meter square should be the answer for this. And then pressure, force is 47.1 divided by 0.0192. Can you get me the answer, please?
2,450.
2,450. Okay, that's very good. And the units are pascals. So again,
Sir,
always I yes.
shouldn't it be 47 newtons?
Why?
Because it's for the original number is 47.04.
04? Really? Oh no, then it should be 47. Okay. You have to, okay. The answer would not change, I think, how much. Okay. Is it clear? So just remember that always write units. It's your responsibility. Otherwise, you're gonna lose 1 mark. And I'm sure you don't want to do that, right? Then this is a very interesting question. And it says, explain why the total pressure on the base of the container is greater than the value calculated. Okay. So I'm just gonna give you, because this question comes from a topic ahead, but I'm just gonna, because you might have done it already. And I just want to tell you that this is because only the liquid pressure is not there. It's also the atmosphere that's acting pressure. So the total pressure is equal to atmospheric pressure and the liquid pressure. So it would be higher. So that's what you should be writing in this. Okay. Good. Interesting. Now, if you guys have any questions, let me know. Zain, Chavez, Najaf, Rohan. Okay. Azim, you should really get your mic fixed, really. Anyway, now going to the next one. So in this sort of question, I would want to give this as homework, okay, because this is pretty easy. But then we'll do this one. And it says the diagram shows a box of dimensions. This, the box rests. Which face must the box rest in order to exert the least pressure? What do you guys say?
Z.
Z.
It's X.
No, X. Sorry.
X.
Yeah.
X.
Yeah, it should be face X. The reason is because it has the largest area. Very good, you people. All right. Now, going to, I don't know if I pasted any of the question. No, I haven't. So let's go forward. Now, most of the questions will be from pressure in liquids. Okay. And pressure in liquids is very, very simple. You don't need to know the derivation or anything else. You just need to know the formula. So the pressure is equal to density of fluids, Fluid basically means everything that can flow. So it's usually liquid and gases, but it could be some form of solids as well. If you put them like in small beads, they also act like fluids. So that's also something. Anyway, so density of fluid times the gravitational field strength, that is 9.8 on Earth, and obviously the depth. Now, pressure is rho gh. That's how we write it as like something to remember. Okay. Now, I just want to tell you something important. Usually, when you put something inside a fluid, the density and the g remains the same. So, pressure depends on number one, obviously the depth. Then it depends on guys, please wait. There's an issue. Okay, so now it depends on depth. It also depends on the gravitational field strength. And it also depends on the density of fluid. Okay, but pressure, there's something that you should remember, and that is pressure does not depend on, number one, let me change the color. I don't want to get mixed. Shape, size, color, etc. It doesn't depend on that at all. It only depends on the three things that I have told you about. All right, is that clear?
Sir, I have a question.
Yes, Zainab. Please
For
go ahead.
density in liquids, does it depend on the area, also the area it's acting on in liquids, sir?
No, it doesn't depend on it. Density only depends on the mass of the liquid and the volume of the liquid. Okay. Now, in liquids, neither the volume changes nor the mass. Okay. It can take the shape of a container, that's true, but not, it can't change its volume. That's why density remains the same. Okay.
Okay, sir.
All right. Hello, Ranim. How are you?
Hi, sir. I'm fine.
Ranim, you just joined today, right?
Oh, yes, sir.
Okay, so we're doing pressure today, and you
Yeah.
can follow along. I'll just repeat what we have done before, just in a bit. Okay. Have you done this chapter before?
Oh, yes.
Okay, then you can follow along.
Okay.
So once we have found the formula for pressure in liquids, we do remember in the questions, then we can go back and look at this particular question. Okay, so first of all, what we're looking at a surface of liquid, which is basically right now it is water. And its density is given by this value, as you can see. Okay. So you have submerged a box that has an area of 2 meter square on like top and bottom, and they have different depths, right? So the top has a depth of 5, the bottom has a depth of 10. So what we need to find is we need to find the pressure, right? So if I find the pressure on top, it's going to be rho GH. And the density of water is 1000. Acceleration due to gravity is 9.8. Oh my God, I still remember that. And it's 5. Can you guys help me find the answer, please?
It's 49,000 pascals.
49,000 pascals. Very good. And then if I want to find the pressure in bottom, at bottom, it's going to be rho GH again. And density is 1000, G is 9.8, and the depth is 10. And that's going to be, I think, 98,000, right?
Yes, sir.
Okay. So if you notice, that's what I'm saying. You might notice something interesting here. Because the depth on the top is less, it means the pressure on top would not be as large as it would be at the bottom, right? And so this is the pressure on top, and the pressure on bottom would be almost double of it, like that, like that, like that. Okay, so pressure on bottom. Now, the thing you need to remember is this is because there is a difference in force. Like the water on top is applying a force here. Let's call this force on top. And water on bottom is applying a force, which is force on bottom, like this. Now, if I want to find the force, let's do it. Let's change the color. I don't like this color. Let's put it, oh, it would match the other one. Let's do. Okay, the force on top then would be pressure times area. Is that clear? How do I know this?
Yes.
Because pressure is force over area. So pressure on top was 49,000 and the area was 2. So it should be 98,000 newtons, right? Then pressure force on bottom would be pressure was 98,000 multiplied by 2. Can you guys help me find this, please?
One 196,002.
196,000 newtons. Very good. Now you see there's a difference, like the liquid is trying to push it up. So the difference in pressure, difference in force got to be 196,000 minus 98,000. Can you also find the difference in force?
That is 98,000, sir.
98,000. Wow. Okay, 98,000 newtons. Okay. Now we're going to come back to why, what this difference mean. But right now we are going to write a small comment for you people and write a note here. As you can see from these two, that pressure increases with depth. So the higher the depth is, the greater the pressure is going to be. Okay. All right. So Imal, Caroline, Hussein, Ismail, do you guys understand this?
Yes.
And Zain, Maham, Moise, Shawez. Okay, cool.
Yes, sir.
Ranim, Rohan, and Saleh.
Yes, sir.
And Yusra and Zainab. Everything is clear, 100%. Should I go forward?
Please wait a second.
Mm-hmm. Okay. Right.
Sir,
Yes. Yes, Imal.
why do you have to find the difference in the force?
I'm just going to tell you in a bit. Okay. There's the reason we did that. Yeah.
Sir, I've
Sorry, come again. You're done, Rani? Okay. So, Rani, do not worry. This PDF that we're solving on, they all have this PDF, like everything was pre-written on it. The things I'm writing, you only need to write those. Okay, you will get the PDF. All right, this one that I'm solving. Why are we talking about this force? Because we want to find upthrust. Okay, everything is okay. Okay,
Yes.
Maham. You're saying Maham is asking me, why did you draw the arrows upwards for the bottom pressure? Right. So Maham, when you add something like in water or any fluid acts pressure from all sides. Okay. On the side, if I had to draw something on the side, this is not like in your course, but I'm just trying to explain it to you. That on the sides, the arrows would be like that. Okay, Maham? So as you go down, they would cause it to increase like that. So pressure acts from all sides. That is why it is not a vector quantity. All right. Is that clear? Good. Now we are going to go towards upthrust. Now upthrust is basically defined as an upward force on a body that is submerged in a fluid, or fluid, which means gas or liquid, okay? And the reason upthrust is this, because when we found the difference in pressure, we realized that this difference in pressure was 196,000 minus 98,000, which came out to be surprisingly 98,000. So what it really means is that this was your box, and on that box, the liquid above the box was trying to act a pressure like this on the top, and at the bottom there was greater pressure, so there was greater force, and the difference of these two is basically the upthrust that is acting, and this is why you guys can float in water, right? Is that clear? Yeah.
Yes, sir.
In fact, you have seen those ships, huge ships, they can also float in water, right? That's something cool. That is why upthrust is such a big thing that we need to know. Okay, you guys can write this down, please. And if you have any questions while you're writing down, please let me know. Okay. Now, should I go forward then? Imal, what is your real name? Is it Imal, is it Manal, or is it Fatma? I'm very confused.
So, so from where did you get Monan?
Okay. All right. I don't know. Your father calls you Manal, you call yourself Imal, and then your WhatsApp says Fatma. So I'm quite confused about that. That's all.
My name is Aimal, my sister's name is Manal, and my mom's name is Fatima.
Oh, okay. All right. Now I understand. Okay, then. So now you see these three things. Now we need to think why. Why that big ship might float, and then a small pin, if you drop it in sea, that goes down, right? That is because when you have a large size volume, right? If something wants to, like, it's sinking, right? So something is sinking, then you should understand that it will have a greater weight. The weight, let's call this W, right, is going to go down, and that's always down. That's why if it's larger than the upthrust, which is basically the upward force, let's call this U, then obviously this object is going to sink. And while it is sinking, because it will move down with the velocity, we've learned in kinematics that it will be opposed by another force, which is called the drag. All right. All right. So it could be air resistance in air and water resistance in water. Is that clear, everyone?
Yes, sir.
That's the velocity. Anyway, if something is rising, like, you sometimes you want something to stay down in water, like a football or something, if you're playing like in a pool, but the football just goes up. Why? Because in that case, its weight is going to be smaller, but its upthrust is going to be much higher because it is lightweight, but it has larger, like volume. And because it will go up now, so the drag force is gonna act down. So the drag always acts against velocity. You guys should remember this. All right. And if something is floating, so in case something is floating, then the only thing you should remember is floating means that it's staying where it is. So the weight of it and the upthrust, they will both be equal. All right, they will be equal. So in this one, you should remember a certain equation that in this one, weight is the largest force, which is equal to the upthrust plus the drag. In this one, the upthrust is the largest force, and it is equal to weight plus drag because drag is always against velocity. And in this one, the weight is equal to upthrust. Notice that I have not drawn drag here. The reason is because if the velocity is zero, it's just floating, then there will be no drag as well. Drag only acts when there is velocity. Is that clear?
Sir, what's a drag?
Drag is the resistive force. Like, you know about air resistance, right, Maham?
Yeah.
So if you go on a car ride and the car is stopped, you take your hand out, you don't feel air, right, on you?
No.
But when the car is moving faster, do you feel the resistance of air on you?
Yeah.
Because the drag force, which is the resistive force to the motion, it basically causes you to, it tries you to slow down, right? And if you take out your hand, it will, you will feel more and more drag as the speed goes up. Okay. Understood?
Okay. So it's basically like air resistance, but in water.
Drag is like a, a basic term. Drag is the real force name. But now, if something is moving in air, we say it's air resistance. If it is moving in water, we say water resistance. If it's moving in ketchup, we would say ketchup resistance. Do you understand? Like that.
Okay.
All of these are have just one name in physics, that is drag force. Understood?
All right.
All right. Anybody who would not understand this, please let me know before we go to the next question.
Sir, upthrust is one of the form of drag, right?
No, upthrust is always there if you put it, if you put something in fluid. It is because
Okay.
of the difference in pressure that we've learned previously in the previous slide, right? It will always be there and will always act upwards, never down. Like weight acts always down, upthrust always acts up in a fluid. Understood?
Yes, sir. So it's a vector quantity, right?
Yes, it is a vector quantity because it is a force. Okay.
Oh, yes, sir.
All right. Now going to a very similar question that came in our exam. I don't know when. 18. Okay. It says shows a hollow metal cylinder containing air floating in sea. Fine. It says the density of the metal used to explain why cylinder floats, right? So now remember that it would float because the density of water is obviously here, but in this one, it has water, it has like steel or whatever the material is, plus air as well. So we're going to write the combined density of what is it? Metal and air is less than density of water. This is why it floats. Do you guys understand? Do you guys understand this? So this is why, when you build ships, in the ship, there is like a hull that inside water, we fill it with air. That's why the ship, that big ship can float. But if you make a plain pin that is very less volume, there's no air inside or nothing like that, it would just sink because it has higher density overall. Understood?
Yes, sir.
So from this question, we also need to understand something new. So please write a note, and the note is that density of object, if density of object is greater than density of water, it will sink because obviously it will have greater weight, and vice versa. If the density is smaller, then obviously it is going to float. All right. Any questions here? Yusra, Zainab, and Saleh, Rohan, everything is clear?
So the question says the density of the metal used to make the cylinder is greater than the density of water. So
Yes.
why does it float?
Because it has also air inside, right? So air and steel, when you combine them, their new density would be overall lesser than water density. Yeah, that's fine. Yeah, no, Kazim, that would not be a correct way to explain this. The reason why atmospheric pressure on the surface of sea, atmospheric pressure would basically try to put it in. So that would not be the right answer. Okay, Kazim? Yeah. So it is only the overall, both combined density of air and steel would actually make it less dense than water itself. That's why. Okay. Anything else? Should I go forward? Now, this question is very similar to one we just did previously. It says the cylinder has a length of this, which is this one, and it floats with 1.2 meters submerged in sea. The bottom of the cylinder has an area of this one. The density of seawater is this one, and calculate the force exerted. Now, I just want to put two things in your attention, and that is, I want to bring your attention towards the depth is always taken, which is submerged, which means that take 1.2 meter as the depth. Taking 1.8 meter would be wrong because depth means from the surface of the liquid to the end. It doesn't mean from the top. All right. So from the surface to the end, from that point. So that is 1.2, not 1.8. Do you guys understand my point? Okay. So
Yes,
this is
sir.
the main conceptual thing that I wanted to bring your attention towards. Now, so first of all, we need to find the pressure. So pressure is rho GH. The density of seawater, I think they gave it somewhere. Where is it? Oh, 1020. The acceleration due to gravity is 9.8. And what is the depth? That's 1.2. Can you help me find this, please?
11,995.
11,995 pascals. Okay. Then we need to find the force. So force is found out by pressure over area. Force over area is pressure. So force would be pressure 11995 times the area is given as 0.8000. Sorry. What you get?
9596.
9596. So I would actually write it as 9600 newtons converted to two significant figures. Please write units. All right. Any questions here? Anything you guys did not understand in this? Please let me know. Okay. Raneen, Najaf, and Shawez, Maham, everything is clear? Do you guys also understand why I have taken 1.2, not 1.8? Okay. And what about Zain, Kazim, Ismail, and Imal?
Sir, could you show the diagram for a second?
Yes, please. Here is this.
Okay.
All right. That's pretty cool. Okay, then.
Sir,
Now, the person who, yes, yes,
we
Rani.
write 9596 instead of 9600 with cutter marks.
No, actually, you should give answers to 2 to 3 significant figures. All right. That's a good way of writing it. Even if you write 9596, that would be okay. All right. Is it clear?
Okay. Yes.
So that's something. They will, however, cut your marks if you don't write units. So you should always write units. Okay. Who's going to tell me what will be the weight of the cylinder? Now, I'll give you a background to this, all right? The object is this force,
The weight.
so it means the weight will be the same as the upthrust. Do you guys understand this?
Yes, sir.
And what do you want to write as an explanation? You will say, when floating, the weight and upthrust are equal. That's what you're going to write. Okay, understood? Very good, very good. You guys are very smart. I like this class very much. Okay. Zen, are you sleeping? Zen? Okay, good. Now, let's go to the next part, all right? So, in the next section, we are going to talk about the atmospheric pressure. Okay. So, keeping of atmospheric pressure in mind, Earth is like this, and around Earth, we got an atmosphere, okay? The atmosphere is basically the air that is surrounding the Earth and it's exerting pressure. So there could be two places, right? Really. So if you look at the Earth, we might realize that at sea, if somebody's like swimming at sea and somebody's like chilling at the mountain top, so they will have different pressures on them. The reason why, because the person who's swimming at the sea will have greater depth of air acting on him. Do you guys understand this? And the person who is at the mountain top, he will have a smaller depth, so he will have less pressure, less atmospheric pressure here, and more atmospheric pressure here. In fact, it's just a thing that you guys need to remember, the atmospheric pressure at sea level is basically the largest atmospheric pressure that anywhere on Earth is. Usually, that pressure is regarded as 1 atm, that is the pressure at sea, and it has a particular value 1.0 times 10 raised to 5 pascals. Now, you don't need to remember this value because the examiner will give you himself, but obviously, it is something just to remember that that would be somewhere on the sea. So everywhere on the in the world, wherever the sea is, this is the same value because sea doesn't have like ups and downs. It is like just same everywhere. Anyway, so atmospheric pressure, although it is basically taken out from the same formula as rho gh, where density is the density of air, and this is the acceleration due to gravity. And obviously this is the depth at which we're looking at it. Previously, we used to have different things about it. We need to find it using mercury barometer stuff that is removed from the syllabus. So if you study it from a book or something, please do not study that because it's gone from the syllabus. All right. Now, so
I'm sorry, can you repeat that?
yes, previously, I'm just telling you, previously there was like mercury barometer and manometer and stuff like this, right? I just want to tell you that is removed from the syllabus. So if you're watching somebody's videos or you're watching like you're reading a book or something, yes, it is gone as well. Hydraulic systems are gone. Okay. So you don't have to do that anymore. Please be very careful about that. Do not waste your time. Okay, you should always look at your syllabus. Your syllabus code is 0625, and you should write on Google 0625 syllabus 2023. That's how you're going to find it. Okay. So, in fact, let me just. Okay. So, the only thing is, I just wanted to. Okay, never mind. Let go of it and go forward. Okay. So now, although we have that removed, but we also need to learn about the concept of total pressure. Okay. Now that's pretty easy. All you need to remember is that when somebody's like inside water surface, not only the water is applying pressure, but on top of it, atmosphere also applies pressure. So total pressure is always atmosphere plus water that we've just studied before as well. So in this question, that's the same concept, where it says on a particular day, the atmospheric pressure is this one, and this value will be repeated so many times. A bubble of gas forms at a point 5 meters below surface of a lake. The density of water is this. Calculate the total pressure. So first of all, we're going to find the pressure of water, which is density of water times 9.8 and times 5. Can you guys help me find this, please? Shouldn't be 49,000?
Yes, sir.
Okay, we just did it. Okay. And then the pressure of atmosphere is given as 1.0 times 10 raised to 5. So the total pressure would always be the pressure of water plus pressure of atmosphere. So we're going to add these together. So 4.9 times 10 raised to 4 plus 1.0 times 10 raised to 5. You're going to take out your calculator and add it up. Wait a second, please. Let me do it. And that's going to be 1.49 times 10 raised to power 5. 1.49 times 10 raised to 5 pascals. Is that clear?
Yes, sir.
Now, obviously, in this question, which is a very important one, if this is the gas bubble we are talking about, and the pressure from the outside on the gas bubble is equal to the value we just calculated. So they're asking what is the pressure of gas in the bubble. So if the bubble is just staying a bubble, it's not expanding, it means the pressure inside would also be the same because it is keeping up that same shape. Do you understand? So you're just going to write 1.49 times 10 raised to 5 pascals, and this is why it is just 1 mark, okay? So if something is neither expanding nor contracting, then what you should know is that pressure inside and outside is the same. Okay? Any questions now? Let me know, please. Saleh, Yusra, and Zainab, Rohan, Raneem, everything is clear? Okay, Najaf, Shafis, Zain, Kazim, Ismail, everything is clear? Caroline and Imal? Okay, very good. Now we have done all of this. And
Sir,
now
just hold on.
okay, sorry.
Thank you. Thank you, sir.
Okay, so now I just want to tell you people a very, very important thing today. So I have given you some practice questions. Now you're going to do these as homework. They're very similar to what we have done now. There are a couple of questions, and I want you to complete this PDF and put it back in. So I'm also going to put the solved version of this PDF right now. Rest of it you need to complete, obviously. So let me put it in your Google class. Okay, Rabim, I'm going to give you the Google Classroom. And if you wish to join us, you should join that too. Okay, so to access everything that we have done and we're doing right now. So we started off at page 53 and we got to go to 63. Okay, 53, where are you? Here you are. Okay, so here, go to this, Google Classroom. And what you to IG crash. Okay. All right. Because I upload my written notes, it does not mean that you do not have to do them. It actually means you have to do yourself. So when I receive your work, I should have your writing on it, not mine. Okay, even if you're copying it. All right. So pressure solved by me. And it is very good that you should, while we are taking the class, you should write the notes because that would help you. And if you're bad at writing and listening, then you can just listen and complete the notes later. Okay, so recently what happened was I deleted my whole drive, and that's why you might not be able to access the previous